Okay, on the common exam, there's going to be an emphasis on four different reaction types. It'll be focused on synthesis reactions, decomposition reactions, combustion. Did I say three? Four. I meant four reaction types. So synthesis, decomposition, combustion reactions, and then precipitation. All right. So this video is designed to provide you a review with what the expectations are for being able to analyze the precipitation reactions. So firstly, um, there are two solubility rules. These are both listed at the top of the screen here, and these should have actually been memorized, like months ago, like 7 months ago. Your precipitation reactions, remember, are classic double replacement reactions. So on the FRQ for the common exam, you could see something like this, and we're going to go through in practice where they give you two reactants, and the first thing that they ask you to do is to complete the reaction. So, or complete the equation. So remember, a double replacement is where the two cations are going to switch the anions, or I usually say switch the dance partners. So the two new products are going to be AgI in this particular example plus KNO3. All right. Usually after defining the two products, then the next thing they usually ask you is to determine which of the two products are a solid. So you can see when you look at both of these compounds that the AgI does not contain a group 1A cation or ammonium, and the anion per se is not nitrate. So this compound here is the solid. If we quickly glance at the other one, the second product here, you can see that it has a group 1A cation, and indeed there is the presence of nitrates. So this remains as a soluble salt. So this would be the solid. I would assume that what they're going to give you should be straightforward this way, as long as you know the solubility rules, that you can deal with the double replacement in terms of being able to identify the products. But you need to look at both of the products and make sure that you've chosen the correct one. Now, what can they do next? They can ask you for the complete ionic equation and for the net ionic equation. And for the complete ionic equation and the net, what that means is you've got to recognize that all the soluble compounds that are here will be completely ionized. They will be completely separated in solution except for the solid. So to separate these guys, I'll just go through, and you're going to separate each of the compounds into their constituent ions. This is a skill like the solubility rules that you should have known a long time ago. There's basically two things that you have to be able to do to carry something out like this, and that is you need to know your elemental ions by heart, and you need to know the polyanions by heart. So the complete ionic equation is going to look like this. An additional complication in all of this is to make sure that the equation is balanced. The first example that I chose to focus on is all 1-to-1 in terms of the mole ratios of these things. So we don't have to worry about it in this equation, but you will have to worry about it in subsequent examples that we're going to do in this short video. So this would be the complete ionic. Again, emphasizing that we have not separated the solid into individual ions. Now, the last part of this would be if you were asked to write the net ionic, and the net ionic equation will only have the ions in it that form the solid. So you can look at it this way. Once you've identified the solid, you can pull that down and rewrite it. Make yourself an arrow, and then write the ions and make sure it's properly balanced. In this case, we don't have to worry about it because it's a 1-to-1 relationship. And this is the net. So what I just did here in the first example in total is something that you might have to do on the common exam. Now, for the rest of the examples, I'm going to motor through them. So the thing is that remember, with a video, you can pause it anywhere you need to. You should have a piece of paper out. You should write down each of the challenges and do them yourself before pushing the video forward to see if you did the right thing. And if you didn't do the right thing, then you should pause the video again and sort out what your problem was. All right, so with that said, let's go ahead and motor through these examples. So in the next one, we have sodium sulfate being combined with copper 2 nitrate. So the sodium is going to pair up with the nitrate. The copper is going to pair up with the sulfate. So, and this is sodium sulfate. Remember that sulfate is a polyanion with a charge of -2 on it, and this is copper 2 nitrate. So the copper and the sulfate are going to match up one-on-one like this. And then the other product is going to be the sodium nitrate, and there's 2 of them. So notice that I'm literally balancing this as I go. All right, so that's step number 1. Step number 2, again, is to analyze the 2 products. The copper is not out of group 1A, and sulfate is definitely not nitrate. So this is the solid. And I'll just circle it. All right, the total ionic equation, the complete ionic equation is going to look like this. It's going to be 2Na plus SO4 minus 2 plus copper plus 2 plus 2 NO3s, NO3 minuses. Make sure when you write these you're putting the charges in, because I'm certain they will ask us to take off points if you don't. All right, and that's the complete. Now for the net, remember on the net that it only includes the ions that make the solid. So I'm going to rewrite my solid, put my arrow here, and then this is going to be Cu plus 2 plus SO4 minus 2, and this would be the net ionic. All right, we got a motor, so we're going to move on to the next example. Okay, at the top of the screen I have cobalt nitrate and sodium sulfide. Again, the 2 cations are going to switch dance partners, so we're going to have cobalt sulfide is one of the 2 products, and the other one's going to be 2NaNO3, sodium nitrate. All right, the common, or the complete ionic is going to be cobalt plus 2 plus 2NO3 minus plus 2Na plus S minus 2, and that's going to be going to, now again, remember, this is going to be the solid because it does not contain a group 1A, and sulfide is not nitrate. Okay, so when we rewrite that, it has to be written together. This is the solid, and then we're going to have 2 Na pluses and 2 NO3 minuses. And again, the net, you can just literally drop down the solid, put your arrow in, and then the ions will just be the ones that are contained in the solid. So this would be the net for this example. Okay, moving to the next one. We have potassium nitrate being combined with nickel nitrate. So again, the cations are going to switch places. So we're going to have nickel nitrate being combined with 2KNO3. And what you see here, when you compare the 2 the 2 compounds, you can see that neither one qualifies as a solid, because in this case we have the nickel, which granted is not out of group 1A, but it is combined. It has been recombined with the same anion, which happens to be a nitrate. So without going we don't have to waste our time here. This reaction is not going to happen. All right, moving on to the next one. So at the top we have iron 2 nitrate being combined with potassium hydroxide. So again, we just go through and recombine the cation with the opposite anion, making sure that everything is balanced. And I'm just balancing on the fly, all right? And then go ahead, all right, I'm getting ahead of myself here. So the iron hydroxide, this is going to be the solid. Why? The iron is not 1A or ammonium, and the hydroxide is not nitrate. So this is the compound which represents the solid, which you guys worked with this one in the lab quite a bit actually. All right, and now when we go to write the complete, we separate all of the compounds into their constituent ions except for the solid. All right, so we can just go through here, make the separations. This is something that you need to practice before the comp, all right? I know what some of you are thinking, that you can just have your notes out and just do this later. And I'm going to tell you right now, you're not going to have time for it. So you need to practice along with this video today. All right, and then to finish this, it's going to be 2K++, 2NO3-. All right, and the net ionic, again, you can pull down the solid, put yourself in an arrow, and then we need the ions. So this is going to be Fe +2 + 2OH-. Don't leave the charges off. A lot of you do that because you don't really know what they are. And I can tell you on the common, they're going to make us reduce pointage because of that. All right, moving on to the next one. We have ammonium sulfate plus barium nitrate. All right, and so again, the cations are going to switch places. Whoops. Let me fix this. I don't need the parentheses here for this one. It's going to be 2 NH4NO3, and then it will be plus barium sulfate. Now, in this one, again, when you look at the two products, you're evaluating, okay, is there 1A or ammonium, and is there nitrate? So this thing right here is not the solid. And then when we look at the barium sulfate, this is out of the laboratory. You should actually know this without any issues. Barium is not 1A, and sulfate is not nitrate. All right, so this guy right here is your solid. That's the solid. All right, so quickly doing the complete, we'll just roll through here and separate these. So it's going to be barium ion plus 2 NO3 minuses. And then we roll to the products. I always put my solid first. It's just a habit. All right, and then we're going to have 2 NH4 plus 2 nitrates. And then again, you can just take the solid and pull it down, because this is where the net comes from. Put in an arrow, and then it's going to be Ba plus 2 plus SO4 minus 2. All right, last two examples. So very quickly, we're going to switch dance partner. So it's going to be PbCl2, getting the balancing right. And then it'll be 2 NaNO3s. All right, it's going to be the lead chloride, which is the solid, because lead is certainly not out of group 1A, and the chlorine is not nitrate. All right, now when we quickly do the complete ionic, we just go through and separate everybody who's not a solid. Make sure it's balanced right. That's one of the reasons this problem is in there, or in this demonstration this morning, because it involves balancing, right? This again is the solid, and then we're going to have 2Na plus 2NO3 minus. All right, and then again I'm going to pull down the solid for the net ionic. Pull that thing down, so it's going to be PbCl2. Put in an arrow, and then we're going to have Pb plus 2Cl minus, and that's the correct balanced net ionic equation. All right, last example. So we have rubidium sulfide being combined with titanium nitrate, switch dance partners. We're going to have titanium sulfide as one of the products, and the other one's going to be two rubidium nitrates. All right, and clearly the titanium sulfide is going to be the solid. It does not have a 1A cation or ammonium, and sulfide is not nitrate, so this is the solid. All right, quickly doing the complete, we're going to have two rubidiums plus 1s plus S minus 2 plus titanium plus 2 plus 2NO3 minus. All right, and we write the solid, we do not separate it. And then we're going to have two rubidium pluses plus 2NO3 minuses. All right, and then again, I'm going to just pull the solid down for the net. All right, put my arrow in, and then we're going to have titanium plus 2 plus S minus 2. And that is the net ionic equation. So on the common exam, you very likely may have to do this entire thing. So make sure that you know your solubility rules by heart, that you know your polyanions by heart, that you know your net your periodic table ions by heart, and that you're able to carry out an exercise like we just did for a lot of different equations. All right, and with that, I'm going to conclude the video.